students, let us take three examples of vertical circular motion. The first example is an oscillating pendulum. The second example is a body moving on a convex surface, whereas the third example is a body moving on a concave surface. In any type of circular motion, you know that one force is necessary, and that is called the centripetal force. So in all the cases, the body must experience a centripetal force, without which the circular motion is not possible. So let us find out that centripetal force in each case. First of all, consider the pendulum. Now suppose this is the lowest position of the pendulum, and at this position it is moving with a velocity v. Now it must experience two forces at this point. One is tension and the other is the weight of the pendulum. And the net of these two forces will provide the centripetal force to the pendulum. So this is T minus mg, and that is equal to mv square by r, because mv square by r is the value of the centripetal force. Now in the second case also, when the body moves on a convex surface, it must experience two forces. One is its weight, that is mg, and the other is the normal reaction from the surface, that is n. Now the net of these two forces will provide the centripetal force to the body, and that is mg minus n. So mg minus n is equal to mv square by r. Whereas in the third case of concave surface, the body is again experiencing two forces. One is mg and the other is the normal reaction, and the net of these two forces will provide the centripetal force, and that is n minus mg. So n minus mg is equal to mv square by r. And now students, you can see that in this case n is equal to mg minus mv square by r, whereas in this case n is equal to mv square by r plus mg. So you can see that in case of concave surface, the normal reaction is more as compared to that on the convex surface. Now अगर ये body highest point पे ना होके इससे पहले कहीं पे होती, and let us say it is making some angle theta, then in this case we should find the component of the forces along the radius, and then we will find the net force to find the centripetal force. So now the body will experience two forces. One is mg, the other is normal reaction, which is on this side, n dash. Now this angle is theta, so its alternate angle is this, so this must be theta. So mg will have a component on this side, which is mg cos theta. Now mg cos theta minus n dash will provide the centripetal force to the body. So I can say that mg cos theta minus n dash is equal to mv square by r. Now student, consider a case when a pendulum is given a certain velocity at the lowest point, whereas tension is required to be calculated at some other point. See, if suppose this is the velocity u that is given to a pendulum of length r, and let us say we have to find the tension of the string at this particular position when it makes an angle theta with the vertical. Now in any question of this nature, we should concentrate on two things. First is the equation of centripetal force, and second is how to find velocity of the body at that particular point, because in this question velocity is given at the lowest position, whereas tension is required at this particular point. So first of all, I will find the velocity at this particular point, and then I will use it in calculating the centripetal force. So how to find the velocity at this particular point? So for that we should use conservation of energy, that the total mechanical energy of the body at this point and at this point should be same, because there is no friction in the question. So let us equate the total mechanical energy at the lowest point and at this particular point. तो इसके लिए हम इस पॉइंट को A मान लेते हैं और इस पॉइंट को B मान लेते हैं. नाउ एट A I write the kinetic energy plus potential energy. Now to find the potential energy, we should have a reference point where I should take the potential energy as 0. तो वो जीरो पोटेंशियल एनर्जी का पॉइंट हम कहीं पे भी ले सकते हैं. जैसे कि इस केस में अगर मैं इसको मान लेता हूँ कि दिस इज द लेवल ऑफ जीरो पोटेंशियल एनर्जी, so I can say that the potential energy at A is 0. So the potential energy is 0 and kinetic energy is half mu square. So it is half mu square plus 0. Now let us find the total energy at B, that is again kinetic energy plus potential energy. Now again kinetic energy is half mv square, whereas the potential energy is mgh, where h is the height of point B from A. So this is height h. Now इस height को calculate करने के लिए I will take the help of this particular triangle. Let us say this point is O, this point is B, and let us say this point is C. So in this triangle, see that the total distance OA is R, and this OB is also R because this is also radius. So in this triangle, if you see that OC is OB into cos theta, so this will be R cos theta. And now we can see that the value of h is R minus R cos theta. So the value of height has come out to be R minus R cos theta. So I will substitute here. So it is half mv square plus mg R minus R cos theta. So I can take R as common. So it is half mv square plus mg R into 1 minus cos theta. This is total mechanical energy at B, and the total mechanical energy at A was this half mu square. Now we can equate these two and we get the value of V. So it is half mv square plus mg R 1 minus cos theta is equal to half mu square. And from here you can see that m is cancelled, and ultimately you will get V square is equal to u square minus 2gr 1 minus cos theta. So this is the value of V, the velocity of the body at point B. Now I can use this value to find the centripetal force at point B, and from that equation we will get the value of tension. Now at B, the body experiences two forces, one is mg and the other is tension. And now I can take component of mg along this string, and because this angle is theta, so its corresponding angle this will also be theta, so this becomes mg cos theta. And now the net of T and mg cos theta will provide the centripetal force. So that is why I can say that T minus mg cos theta is equal to mv square by R. And we know that V square is this, so if you substitute this value here, you will get the value of tension. So these are our steps to find the tension in the pendulum string at a given point. Now students, आप लोग इन दो इक्वेशंस को इस पर्टिकुलर केस के लिए जनरल इक्वेशंस की तरह से भी यूज़ कर सकते हो, जैसे कि ये इक्वेशन आपको हमेशा टेंशन प्रोवाइड करेगी और ये इक्वेशन आपको हमेशा वेलोसिटी प्रोवाइड करेगी एट ए गिवन पॉइंट. स्टूडेंट्स, अब हम इन इक्वेशंस को यूज़ करके डिफरेंट पॉइंट्स पे टेंशन और वेलोसिटी कैलकुलेट करके देखते हैं. इनमें ध्यान ये रखना है कि जो एंगल थीटा है वो हमने इस लोअर वर्टिकल लाइन के साथ लिया है. जैसे कि अगर मैं इस पर्टिकुलर जगह पे टेंशन कैलकुलेट करना चाहता हूँ तो यहाँ पे थीटा को मैं 0 डिग्री लूँगा, and if I substitute here 0, then I get T minus mg is equal to mv square by R. So this is the equation at this particular lowest point. Whereas if suppose I have to apply the same equation for this particular position when the body is here, so in this case theta becomes 90 degree. So when I put here 90, cos 90 is 0, so I get T equal to mv square by R. Whereas when the body reaches at the topmost position, then this total angle becomes pi or 180 degree. So if I put here cos 180 is minus 1, or cos pi is minus 1. So minus 1 and this minus will become plus. So at the highest point the equation becomes T plus mg is equal to mv square by R. Of course V is the velocity at different points. It may be same in case of uniform motion and it may be different in case of non-uniform motion. Students, अगर हम इन इक्वेशंस को यूज़ करके टेंशन कैलकुलेट करते हैं स्ट्रिंग में एट द लोएस्ट एंड एट द हाईएस्ट पॉइंट, देन एट द लोएस्ट पॉइंट आई गेट T इक्वल टू mv square by R plus mg, and from this equation I get T equal to mv square by R minus mg. and from the equation we can see that this is the maximum tension during the vertical circular motion and this is the minimum tension during the vertical circular motion. So this is T max and this is T minimum. Now if suppose I subtract these two, so I get T maximum minus T minimum equal to 2 mg. Now this is the difference of the maximum and minimum tension in case of a vertical circular motion of a simple pendulum when it rotates or when it moves with constant speed. Now you may remember this particular answer as a standard result. Students, one thing is sure that when a pendulum moves in a vertical circular motion, then the tension in the string is maximum at the lowest point whereas it is minimum at the highest point. So this tension will never become zero whatever way the velocity be. But if suppose we start decreasing the velocity, then at a certain velocity when mv square by r becomes equal to mg, T minimum may become 0. So this velocity we can find out by equating mv square by r is equal to mg and m is cancelled, so v is equal to under root of rg. Now this is that particular velocity at which the tension at the highest point becomes 0. Therefore to complete a vertical circular motion, I can say that the velocity of the bob at the highest point should be greater than under root rg, or we can say in case of numericals we can take it as the minimum velocity that the body should have or that the bob should have at the highest point to complete a vertical circle. तो स्टूडेंट्स हमने देखा कि अगर हाईएस्ट पॉइंट पे बॉब की वेलोसिटी अंडर रूट आर जी से कम होती है तो इट विल लीव द सर्कुलर पाथ. तो अगर इसने सर्कुलर पाथ छोड़ दिया तो फिर ये किस पाथ को फॉलो करेगा? सो एक्चुअली इट स्टार्ट्स मूविंग अंडर ग्रेविटी एंड अंडर ग्रेविटी इट फॉलो पैराबोलिक पाथ. स्टूडेंट्स, अभी तक हम बात कर रहे थे एक सिंपल पेंडुलम के बारे में जिसमें कि वी हैव ए पॉइंट मास कनेक्टेड विद ए मासलेस स्ट्रिंग. अब सपोज कि अगर हमारा पॉइंट मास किसी मासलेस रिजिड रॉड के साथ में कनेक्टेड होता तो क्या आप बता सकते हैं कि हाईएस्ट पॉइंट पे कम से कम कितनी वेलोसिटी होनी चाहिए थी इन ऑर्डर टू कंप्लीट अ वर्टिकल सर्कल? सो दैट्स राइट, द वेलोसिटी में भी 0, क्योंकि ए पॉइंट मास कनेक्टेड टू अ स्ट्रिंग may leave the circular path, but in case of a point mass connected to a massless rod which is rigid, it cannot leave the circular path even if it comes to rest at the highest point. Now students, ये हम देख चुके हैं कि पूरा एक सर्कल कंप्लीट करने के लिए पेंडुलम के पास हाईएस्ट पॉइंट पे जो वेलोसिटी होनी चाहिए वो है अंडर रूट आर जी. नाउ द क्वेश्चन इज कि इस वेलोसिटी को ऑब्टेन करने के लिए कितनी वेलोसिटी हमें लोएस्ट पॉइंट पे देनी चाहिए. इसका आंसर फाइंड आउट करने के लिए वी कैन अप्लाई कंजर्वेशन ऑफ एनर्जी और आई कैन ऑल्सो यूज this equation directly that I obtained by using conservation of energy. So this equation says that V square is equal to U square minus 2gr 1 minus cos theta. What is theta here? So theta is the angle from lower point to the highest point. So this angle will be 180 degree or pi radians. So if I put here 180 degree, so cos 180 is minus 1. So this minus and minus becomes plus, so this becomes 2. So that is why it becomes V square is equal to U square minus 4gr. But what is V? So I know that velocity is under root rg. If I substitute here, so square of this, so under root rg ka square, it is rg is equal to U square minus 4gr, and ultimately I get U square is equal to 5gr or u equal to under root of 5gr. So this is the minimum velocity that I should give at the lowest point to a pendulum to complete a vertical circle. स्टूडेंट, यहाँ पे मैं आपको एक बात बताना चाहता हूँ कि ये वेलोसिटी है इस बॉब की विद रिस्पेक्ट टू दिस पॉइंट ऑफ सस्पेंशन फ्रॉम वेयर द पेंडुलम इज सस्पेंडेड. So this means it is actually the relative velocity of the bob with respect to the point of suspension. इसका मतलब मैं ये कहना चाहता हूँ कि अगर पॉइंट ऑफ सस्पेंशन के रेस्पेक्ट में इस बॉब को हम इतनी वेलोसिटी देते हैं तो ये एक पूरा वर्टिकल सर्कल कंप्लीट करेगा अबाउट द पॉइंट ऑफ सस्पेंशन. अब हम इसका उल्टा भी सोच सकते हैं कि अगर हम बॉब को वेलोसिटी ना दें और पॉइंट ऑफ सस्पेंशन को इतनी वेलोसिटी दें तो भी क्या ये पूरा सर्कल कंप्लीट करेगा? So yes, even in that case, if suppose I move the point of suspension with a velocity equal to under root 5gr or greater than this, then the bob will again complete a vertical circle about the point of suspension. तो स्टूडेंट्स, क्या आप बता सकते हैं कि मैं इसको कितनी वेलोसिटी दूं कि ये पेंडुलम ए से और सिर्फ बी तक ही जाए, इसका मतलब इट शुड मूव फ्रॉम ए टू बी, एट बी इट शुड कम टू रेस्ट एंड देन इट शुड कम बैक. To find its answer, again we can apply conservation of mechanical energy, or also we can directly apply this equation that we obtained by applying conservation of mechanical energy. So let us apply this equation directly. V square is equal to u square minus 2gr 1 minus cos theta. Now what is theta in this case? Theta is this angle which is actually 90 degree or pi by 2 radians. So I know that cos pi by 2 is 0. So this quantity becomes 0. What is V? The velocity at V is 0. So it is 0 is equal to u square minus 2gr 1 minus 0. This means u square is equal to 2gr, or u is under root of 2gr. So this is the velocity required at the lowest point so that the pendulum reaches this position and then it comes back. स्टूडेंट इसका मतलब है कि अगर लोएस्ट पॉइंट पे वेलोसिटी अंडर रूट 2gr होती है तो ये इस हॉरिजॉन्टल पोजीशन तक जाता है एंड देन इट कम्स बैक, और अगर इसकी वेलोसिटी अंडर रूट 2gr से भी कम होगी तो पेंडुलम विल नॉट रीच इवन द पॉइंट बी, but it will come to rest before point B and then it comes back and start oscillating about the lowest position. So that is called the condition of oscillation. This means if u is less than or equal to under root 2gr, the bob or the pendulum will oscillate about the lowest position. And if suppose the velocity of the bob at the lowest point is under root 5gr, then it completes a vertical circle. So at under root 2gr it reaches this point. At a velocity of under root 5gr it completes a vertical circle. So what is the situation when the velocity of the bob is between under root 2gr and under root 5gr? In that case actually the bob will cross this horizontal position but will not reach the highest point and it will leave the circular path in between. That means in this particular quadrant the bob will leave the circular path, and once it leaves the circular path the tension in the string becomes 0 and finally it follow a parabolic path. So this is the condition of leaving the circular path. This means if velocity is between under root of 2gr and under root of 5gr, then the bob will not complete a vertical circle but it will leave the circular path and starts following a parabolic path. So now we have got three important velocities for the pendulum in vertical circular motion. First is under root 2gr. This is the velocity when the pendulum reaches this horizontal position. If the velocity is less than under root 2gr, it will oscillate about the lowest point. If suppose the velocity is under root 5gr, then it will reach the highest point and complete the vertical circle. And third is when the velocity is in between these two, then the pendulum will cross the horizontal position but it will not reach the highest point, but in between the tension in the string becomes 0 and it will leave the circular path and start following a parabolic path. तो क्या हम वो पोजीशन निकाल सकते हैं कहाँ पे बॉब सर्कल को छोड़ेगा? तो yes, we can find out that position by using these two equations. You just have to do one step, that put v square here and put t equal to 0 and you will get the value of theta, and this is the position where tension will become 0 and the bob will leave the circular path. Now student, my next question is that a body is moving on a horizontal circle of maximum radius inside a fixed spherical chamber of radius r such that the normal reaction from the surface is 4 times the weight of the body. If the body moves with the same speed in a vertical circle inside the same chamber, will it be able to complete a vertical circle? Now students, let us assume that the body is moving inside this spherical chamber and it is moving on the circle of the maximum radius. This means it must be in the equatorial plane. So which force will provide the centripetal force to the body? Now this is the normal reaction from the surface. So the normal reaction is N, and this N provides the centripetal force, that is mv square by r. And it is given in the question that normal reaction is 4 times the weight of the body. So in place of N I can put 4 mg. So this is equal to mv square by r. So m is cancelled. So I get v equal to 2 under root gr. Now this is the speed with which the body is moving. स्टूडेंट्स, क्या आपको याद है कि जब कोई बॉडी वर्टिकल सर्कुलर मोशन को कंप्लीट करती है तो व्हाट इज द मिनिमम वेलोसिटी रिक्वायर्ड एट द हाईएस्ट पॉइंट? सो दैट्स राइट, इट इज अंडर रूट जी आर. नाउ दिस वेलोसिटी इज ग्रेटर देन दैट. So this means we can conclude that if the body will move with the same speed on a vertical circular path, it will be able to complete a vertical circular motion. Now students, let us consider one more question. With what minimum speed v must a small ball be pushed inside a smooth vertical tube from a height h so that it may reach the top of the tube? And 4 options are given to you. स्टूडेंट्स, इस क्वेश्चन में खास बात यह है कि हमें वेलोसिटी देनी है ए पे सच दैट द बॉडी शुड रीच एट पॉइंट बी. नाउ सो व्हाट शुड बी द मिनिमम वेलोसिटी रिक्वायर्ड एट बी? सो इट शुड बी 0. सो आई शुड अप्लाई कंजर्वेशन ऑफ मैकेनिकल एनर्जी बिटवीन ए एंड बी. नाउ व्हाट इज द टोटल एनर्जी एट ए? सो इट शुड बी पोटेंशियल एंड काइनेटिक बोथ, and similarly at b also it is the sum of kinetic energy and the potential energy. Now in order to find the potential energy I should have a zero reference. So let us take this level as the reference of zero potential energy, and now I will write the total energy at A and the total energy at B and I will equate them. Now what is the total energy at A? So it should be half m v square plus 0 because I have taken this level as the level of zero potential energy. And then what is the total potential energy at B? So it should be mg h. What is h? H is the height of B with respect to A, and now you can see that if this hole is r, this is h, so this must be r minus h, and from B to C this is r, so the total height becomes r plus r minus h. So it is mg r plus r minus h, and plus what is the kinetic energy at B? So it is 0, so kinetic energy is 0. Now we can solve this equation, and to solve the equation I can cancel mass from both the sides and I will cross multiply 2. So it is v square is equal to 2g, and in the bracket I have 2r minus h, so v is under root of 2g 2r minus h, and this option is given as option D. Now स्टूडेंट, यहाँ पे एक ध्यान देने वाली बात यह है कि अगर ये क्वेश्चन एक पेंडुलम का होता तो उस केस में इस पेंडुलम को हाईएस्ट पॉइंट तक पहुँचाने के लिए हमारे को जो हाईएस्ट पॉइंट पे वेलोसिटी है वो एटलीस्ट अंडर रूट जी आर लेनी होती, जबकि इस केस में हमने माना है कि पॉइंट बी पे वेलोसिटी 0 है. सो यहाँ पे सॉल्यूशन डिफरेंट हो जाता. अगर ये पेंडुलम है देन आई विल टेक द काइनेटिक एनर्जी एट बी एज हाफ एम वी स्क्वायर where velocity v is under root gr, that is the minimum velocity required to complete a vertical circle. So in that case our answer will be different. Now students, let us consider this question that the breaking tension of the string of a pendulum is 10 times the weight of the bob. At the highest point what maximum velocity can be given to the bob so that it complete vertical circular motion? So the situation is that you have to give initial velocity u at the highest point of the pendulum such that the maximum tension is 10 times the weight of the bob. Now we know that the maximum tension reaches at the lowest position. So here the tension maximum is equal to 10 times the weight of the bob, and this is the weight mg. So the net of the two forces will provide the centripetal force to the bob. So that net force will be 10 mg minus mg. So 10 mg minus mg, which is basically 9 mg, and this provides the centripetal force mv square by r. So if I cancel m, I get v square is equal to 9 gr, or v is equal to 3 under root gr. So we have got the velocity of the pendulum at this point, and this velocity is 3 under root gr. Now once we get the value of velocity at the lowest point, now I can apply conservation of mechanical energy at the highest point and at the lowest point. Now to apply conservation of mechanical energy, we know that we should have a zero reference for the potential energy. So let us take the point B as the zero reference of potential energy. So here the potential energy is taken as 0. So with respect to this, the potential energy at A will become mgh, where h is this height, that is 2r. So the total potential energy at A is mg2r, plus the kinetic energy at point A is half mu square and this total mechanical energy at A should be equal to the total mechanical energy at B. Now here the potential energy is 0 and the kinetic energy is half mv square, where v is this 3 under root gr. So square of this will be 9 gr. Now we can solve this equation and we get the value of u as under root of 5 gr. So this is our final answer. Students, let us consider one more question, that there is a mass m which is placed on a rough horizontal surface. It is connected to a string, and then there is another identical mass b which is also connected with the string AB, which is kept horizontal. Now the system is at rest in this particular position. Now the question is, find minimum value of mu so that mass on the table remains stationary before and after burning string AB. ना इस क्वेश्चन को सॉल्व करने के लिए हमें दो वैल्यू म्यू की निकालनी पड़ेंगी, एक स्ट्रिंग ए बी को बर्न करने से पहले और एक स्ट्रिंग ए बी को बर्न करने के बाद. फिर दोनों में जो हायर वैल्यू होगी वो हमारा आंसर होगा. Now before burning, let us make a free body diagram of both the bodies and we apply the condition of equilibrium. That means we will find the component of the forces along x and y axis or in any two mutually perpendicular directions, and then we will equate the opposite forces. So let's make a free body diagram of mass small m, first of all, which is placed on the rough horizontal surface. Now this is acted upon by a force tension which is of the string, and then there is another force mg. Then there is a normal reaction from the surface, and then there is another friction which is basically mu into n. Now in this case n is equal to mg, so n is equal to mg, and if I substitute here, then friction is equal to mu mg, and because the body is at rest, so I can say that this T should be equal to friction force. So T is equal to friction force, which is mu mg. Now we consider the second mass small m, which is acted upon by three forces. So one is its own weight, which is mg, the other is the tension from the string AB, and the third one is the tension which was this one, which is mu mg, and this tension is acting at an angle of 30 degree. So I can find the component of the tension. One is on this side, the other is on this side. Now this will be mu mg sine 30, and which is balanced by t dash. So mu mg sine 30 is balanced by t dash, and this vertical component of mu mg is mu mg cos theta, which is equal to mg. So mu mg cos theta is equal to mg. Now this m and this m is cancelled, so I get the value of mu. G is also cancelled, 1 upon cos theta, and theta is given as 30, so cos 30 is root 3 by 2, so this value is 2 by root 3. This is the first value of mu that we have got using equilibrium concept. Now student, to find the second value of mu, we should burn the string. When the string is burned, this mass will start following a circular path. When it will reach the lowermost position, then the tension in the string becomes maximum, and when this maximum tension will act on this mass, there are chances for this body to slide, but we want that the body should not slide. That means that maximum tension should be balanced by the friction force. So we will balance the maximum tension with the friction, and we get another value of mu. So this is the concept. So let us find that how much will be the maximum tension when the string AB is burnt. Now consider that part. This is like a pendulum which is making an angle of 30 degree with the vertical, and it has a length of 1 meter. Now when it is released, when it reaches this point, then at this point tension T and this mg will act on the mass. Now the net of the two will provide centripetal force to this mass, and that is T minus mg. So T minus mg is equal to mv square by r, and if suppose I can find the value of v, then we can find the value of tension. Now to find the value of v, we will apply conservation of mechanical energy. Now when this mass reaches this point, how much height will it lose? So can we find? So yes, if this length is L and this angle is 30 degree, so this will be L cos 30. from this triangle, you can see that if this angle is 30 degree, this length is L, then this is L cos 30. Now because this total length is also L, so I can say that this H is equal to L minus L cos 30. So H is equal to L minus L cos 30. L is common, so it is 1 minus cos 30. Length is given as 1 meter, so it is 1 minus cos 30 is root 3 by 2. So I get 2 minus root 3 by 2. This is the height through which the body comes down. Now I apply conservation of mechanical energy, that loss in potential energy is equal to gain in kinetic energy. Now what is the loss in potential energy? So that loss in potential energy is equal to gain in kinetic energy. Now the loss in potential energy is mgh and gain in kinetic energy is half mv square, where v is the velocity at the lowest point. Now m is cancelled, the value of h I know and the value of g I know, so it is g. H is 2 minus root 3 by 2, this is half v square, this 2 is cancelled, so I get v square is equal to g 2 minus root 3. Now I will substitute this value of v square here and I will get the tension. So T minus mg is equal to m. V square is this, g 2 minus root 3 divided by r. And now what is r? R is the radius in which this is moving and this is given as 1 meter. So this quantity is 1 meter, so I get T is equal to mg 2 minus root 3 plus mg, because radius is 1 meter and this mg is taken to the right side. So now this is mg within bracket 2 minus root 3 plus 1, and ultimately I get mg, it is 3 minus root 3. This is the value of tension when the mass reaches the lowest point. Now this particular tension will act on the body which is placed on the surface. So that body will experience the following forces. One is the tension T, which is mg 3 minus root 3. The next is its own weight, which is mg. Another force is the normal reaction from the surface, and the last one is the friction, which is mu into n. Now because the body is at rest, so all the forces must be balanced. So I can say that n is equal to mg and mu into n is equal to this force. So mu into n is equal to mg 3 minus root 3. Now n is again mg, so this mg and this mg are cancelled, so I get mu is equal to 3 minus root 3. I can take as 1.7, so this value comes out to be approximately 1.3, whereas the previous value that we obtained before burning the string, it was actually mu 2 by root 3, and this value comes out to be 1.1. So out of these two values, this value is greater. That is why our answer should be 1.3.